Good morning, good afternoon, good evening, everyone. Welcome to the first edition of our ZTNA Table Talks. I'm Ixa Gerard, and I'm thrilled to have you all join us today for this exciting new monthly webinar series where we're going to delve into the world of the Zero Trust Network Access. Today's session is titled, What's the network security difference between direct routed and cloud routed ZTNA? We will explore this topic in depth and provide valuable insights from our ZTNA experts presenting today: Jim Anthony, SVP of Field Engineering, Steve Bledsoe, Sales Engineer Manager, and Justin Yentile, Director of Sales Engineering. Before we kick off, a couple of things to note. This webinar is being recorded, and you will receive the recording within about 24 hours. Without further ado, I'll pass it over to Jim and his team, and they'll start the session. Now over to you, Jim.
Thank you, Ixta, for the introductions, and thank you everyone for jumping on. It looks like we've got participants from around the world. So again, as Ixta just said, good morning, good afternoon, and good evening to all of you that have jumped on and given us an hour of your time today. Without further delay, let's jump right into it. I have with me on the line here one Mr. Steve Bledsoe. He's already been introduced by Ixta, but Steve's going to be playing the part of the customer use case expert here on our chat this morning, our roundtable, and we've also got Mr. Justin Yentile, who is going to be our technical demo master. Now, both Steve and Justin will be jumping in to give various demos along the way, further explaining some of the points that we're making in this cloud routed versus direct routed conversation that we're about to have. And of course, I'll be your roundtable MC, and we'll get through this as best we can. Like Ixta said, this is the first of our roundtable series that we've done here in 2024. We'll give you a link at the end to participate in some other ones in the future if you guys find this interesting and useful. And we will have different topics every month. So that's the plug. So today's topic, January 23rd, 2024, we're talking about direct routed and why does it matter? There's a lot of competition out there in the zero trust space, the bandwagon, if you will, right? So if you think about seeing and hearing and listening to all the marketing jargon that's out there, there's a lot of zero trust talk. Zero trust network access vendors are out there. I've displayed a lot of logos on the screen there and sort of put a box around them representing this cloud-oriented, POP-oriented concept, the architecture that a lot of these vendors employ into that space. And this, we're going to be targeting some conversations around this in the roundtable talk today. What is the difference between a cloud-routed or POP-oriented solution and a direct-routed solution like AppGate SDP? But not to belittle or shortchange some of the other concepts that are out there. There's a lot of vendors that are playing in the SD-WAN space that are also having zero trust elements in their marketing message, right? So they're claiming to be zero trust oriented. They're doing some things that are, preventing access, and they're adding to some of that confusion and that bandwagon approach. Your traditional VPNs are out there doing the same thing. Everybody's talking about how they apply to the zero trust world and what that looks like. We can talk through some of those issues as well. As we work through it, you may hear some information from some of the PAM vendors, privileged access management, and how they might play in the zero trust space. They've got some strengths and some weaknesses as well, some capabilities that are unique to their set in the market. But then again, do they do everything that some of these zero trust network access players do is the real question. There's a lot of hardware vendors out there, a lot of hardware-focused vendors that will have you believe that their zero trust solution is something that you should evaluate and look at. And again, the identity management providers are also adding to the confusion with their zero trust messaging. There's a lot of categories here, right? There's a lot of confusion, a lot of things going on in the market. Web proxies are also another category where this zero trust bandwagon approach comes into play. But are all of your applications web oriented? Are all of your applications browser based? That's some of the challenges that these guys run into. And then again, you've got some good messaging and good literature coming out of Microsoft and VMware and Google with their Beyond Corp Enterprise concepts. But a lot of these guys are limited to their platforms as well, right? So if you want to tap into that Microsoft security stack in a whole and meaningful way, typically you're going to be tapping into the Microsoft platform and the Microsoft operating systems. There's some exceptions to that, and Google is the same way, right? If you want to take advantage of Beyond Corp, there's some Google-oriented things that you've got to be prepared to lock into. And then there's another category that I call it the marketing confusion category. There's these companies that are out there that have a lot of different scenarios. They've got a lot of different concepts that they apply to. They've got some SD-WAN solutions. They've got some identity-oriented solutions, web proxy. So there's a lot of confusion coming out of that as well. And I haven't even touched on some of these other categories like CASB or secure DNS or the XDR, MDR marketplace, or even your antivirus players. Bottom line is, here at Appgate, we think that Appgate SDP is really differentiated among all of these different categories and all the different vendors. Of course, we compete directly in the ZTNA space with the cloud-oriented, POP-oriented vendors that you see in the upper right. But in a roundabout way, we compete or at least go head-to-head with some of these other vendors as well in a comparison with what we do in terms of the features that we deliver, the architecture that we have, and some of the cost benefits that you can achieve by deploying an Appgate SDP solution in your environment. So let's get focused in on the cloud routed versus direct routed conversation. So at a high level, what is cloud routed and direct routed? Well, and I'll have Justin and Steve chime in to help me cover off on some of the color commentary between these two different models. But at a highest level, think about a direct routed architecture as a concept that the end user traffic flows from the end user directly to the data center or the cloud location where the application services live. There's no POP in the middle. There's no internet-based service that's applying logic or access rules or access methods. No cloud-based service doing encryption and de-encryption. There's a direct routing between the end user and the location where the services live. In the cloud routed model, that end user is actually connecting to a cloud-based service where the logic is applied, whether that logic involves, who are you and whether or not you have access to certain applications. But perhaps there's some encryption and de-encryption that's happening there for some packet inspection and things like that. But the point is, you're going up through some cloud-based service before you get access to the data centers that house your applications. Justin, Steve, any other color commentary you'd like to add here?
Yeah, Jim.
Go ahead, Justin.
Steve.
All right.
So
you're thinking about cloud, right, in a very different context. We've always been kind of conditioned in the past to think cloud equals good. Everyone's going to the cloud. Let's go to the cloud. And I'm not saying that's not correct, right? For a lot of things, cloud has made our lives a lot easier, no question about it. But if you think about private application traffic, right, that inherently does not need to traverse any third-party infrastructure to accomplish its goals, right? It does not require your traffic to go somewhere and then come back to somewhere else that you have no control over, that you have no insight into, that you have no real ability to validate and vet exactly what's going on with your data in that paradigm. So sorry, Justin, go ahead.
I just wanted to expose, some of the other inherent, challenges with routing your traffic artificially through someone else's infrastructure. By doing so, you're artificially introducing attacks in the form of increased latency. Oftentimes, there are limitations or constraints on the amount of throughput, or the ZTNA vendor will charge you for that throughput and make it very expensive. And then finally, there also are oftentimes limitations around the protocols or applications that you can actually run over some of these cloud routed solutions. And so by directly routing the traffic from an endpoint device to a policy enforcement point that actually lives in your networks, in your data centers or your cloud environments, we're able to help you overcome those challenges and also to extend the functionality of our solution to help you solve many more business problems than a lot of the cloud routed solutions are limited to.
Those are great comments, guys. And so let's spend the rest of this hour talking about some of the extended functionalities and some of the ways that we avoid the pitfalls associated with a cloud routed solution. So let's jump right into it with our first concept. So let's talk about bidirectional access enforcement. What does this actually mean? I think the concept here is the idea that most of your traffic is going to flow from the end user up to the data center where services are going to be accessed by that end user. But are there scenarios where the data center needs to initiate a connection to the end user for some reason? Justin, why don't you talk us through some of these ideas about how that data center service might actually need access to the end user's device and what that means from a down entitlement sort of concept. What does that mean?
Yeah, absolutely. So there are several different ways that our customers oftentimes do come to us, and they'll tell us that they need to be able to reach down towards in the direction of an end user's device, or down to a branch office that maybe they don't have a VPN concentrator at today, or something like that. And some of these reasons would be summarized with think of a help desk administrator that needs to be able to administer via either RDP or SSH into an end user's workstation. That end user is at home. How do you reach that workstation? Obviously, a lot of other solutions are going to have trouble with that, and it's going to force you to have to invest in some other third-party solution to meet in the middle or something like that. AppGate can help you to overcome that directly. Another good example is remote vulnerability scanning. Obviously, we live in an age where vulnerabilities exist, unfortunately, and there's nothing we can do about them, but we have to try to mitigate them. And so for your endpoint devices that are out in the field, do you have a good grasp on being able to scan them regularly for vulnerabilities? And so by having a server-initiated connection, you're able to actually reach those endpoint devices with AppGate SDP.
Justin, really great points. Is there a way that you could actually show us some of this in action?
Yeah, absolutely.
All right, I'm going to stop my screen share and let you pick it up.
All right. So we're going to start with a quick description of the environment here. So before we actually get into the demonstrations, it's important for you to understand what I'm showing you here. So here you have an end user. This is going to represent me for the purposes of our demonstration. And what you see here is a representation of my AppGate demo environment. And so I, as an end user, have an AppGate client deployed on my laptop here. And as such, when I'm logged in, I'm actually connected to a whole bunch of gateways around the world in various different types of environments, spanning across public cloud and private data centers. And in addition to that, you'll also see at the top of this diagram an end user. This represents any end user from anywhere in the world. I've put him in a home office, and you can see that he also has an AppGate client installed. And his AppGate client is effectively connected to one of the same locations to which my AppGate client is connected. And by doing so, what this allows for AppGate to do is I can be served an entitlement, or essentially a policy that allows me to reach up via this gateway in our AWS environment, and then down to his endpoint in his home office. And so that's what I'm going to be demonstrating to you in just a moment here. But so let's dive right in there. So if I first switch over to, this is my AppGate admin console. And I just want to show you that in this AppGate admin console, there is an active session for a user. It happens to have my name also, but so Justin is on a host name of this random host name of Justin Yenti 0 CAA. That's going to be important in just a few minutes here. So I just want to point out to you that the user that's logged into the AppGate client on that remote workstation is named Justin. And what I'm doing next is I'm going to, oops, I'm sorry. And I just want to also point out that this endpoint device has an IP address, a tunneled IP address of 192.168.104.65. This is a private IP address, obviously. And if I switch over now to my Microsoft Remote Desktop, here I'm going to show you what my connection looks like here. So the connection is pointing at that 104.65 IP address. And I'm actually able to, because I've been served the appropriate entitlement to do so, to directly RDP into that workstation. Now, I'm actually logged in now to this workstation remotely, obviously. And then, as you can see here, I can work perfectly fine with this remote user's PC. Now, you might be asking what would happen if the user weren't logged in and we needed to modify or manage something on the endpoint. And so, no problem. And so again, coming back to my pointing out to you the host name on that workstation, If I come back here and search for, again, that same host name, Justin Yenti 0 CAA, you'll see here that the username that's logged into the AppGate client after I have logged out of the OS is no longer me. And so this is highlighting a second concept here, wherein AppGate SDP employs an always-on client option, where even if an end user is not logged into the workstation, that workstation can be connected to the network. Now, the always-on user has a different tunneled IP address. So we see here in the tunnel IP details for this session that this computer now has a 104.35 IP address. So if I switch back over here to remote desktop, you'll see that I've created a second connection here, and I've got it set up to point at this 104.35 IP address. So now, even without the end user logged into the operating system, again, that AppGate client is serving a basic entitlement that allows for me from my Mac here to reach up through that gateway in AWS and then down to the end user's workstation. So I'm actually able to administer this workstation regardless of whether the user is logged in or not. And so, hopefully that helps to exemplify it. With that said, I'm going to hand it back over to you, Jim.
Very good demo, Justin. There's a lot of moving parts in that demo, and it's fairly complex, but hopefully that made sense to everybody on the call. I think what just to summarize what you demonstrated here is the idea that using AppGate, you can connect bidirectionally through those gateways and gain access to, not only as a user, gain access to services in the data center, but gain access in a downward fashion, or grant access in a downward fashion to any of the end user's devices as well. Remote desktop administration is a prime use case for that. No extra software needed, no extra bits in the middle that would make that connection happen. It's all AppGate
Exactly.
at that point. Very good. All right, so let's go to the next topic here. Universal ZTNA. This is something that's gaining more market traction. What exactly does universal ZTNA mean? Well, first of all, let's define it, right? So the concept is that all users access all resources in the same way at all times. What I didn't say there is that, when you're in the office, you choose not to use any access method, and when you're outside of the office, you choose to use some access method. This universal ZTNA is the opposite of that. You're using the ZTNA solution no matter what. Because the ZTNA solution presumably brings so many things to the table, going way beyond identity management and also understanding posture of device, posture of surrounding elements like time of day, geolocation, and things like that. So you're using this ZTNA solution to access your private workloads, your protected workloads at all times. So this includes on-prem users as well, right? So think about the idea that a corporate headquarters houses not only users, but also a data center. And now those users need access to something in that data center, right? Well, in a cloud routed scenario, correct me where I go wrong, guys, but in a cloud routed scenario, that user is typically going to head out to the cloud, hit that POP where some logic is going to be applied, and then be routed back into that data center. And I've got on the slide that second to last bullet there, that cloud routed solution introduces some crazy internet bandwidth charges. Twice you hit the outbound to the POP as one path, and then you hit the inbound to the data center as the other path. Steve, can you add more color to that twice comment that I've put in that slide?
Yeah, I'd love to. So actually, I think maybe it would make sense for us to show it live if we
Let's
can.
see it. You're prepared to do a demo then. Let's go into it.
Let's do a demo. So you hit the nail on the head, Jim, right? It makes absolutely no sense for someone to hairpin traffic out to the cloud just to turn around and come back in if you've got resources that are co-located with you in your office, right? Traditionally speaking, if you've got a ZTNA solution already, that's not going to be possible. So now you're stuck either kind of managing two solutions, right? One is going to kind of look at the posture and security of your on-prem folks, maybe using some legacy stuff for that. And then you have another solution for your remote users, or maybe using the same one, but it's not going to give you that same level of flexibility around your routing and your network performance that you would if you had one universal experience. And also your users have to learn how to use two different sets of security tools potentially. And you don't really want to do that, right? So what I'm going to show you here is a pretty straightforward demo. I'm kind of a fictional corporate office here in my house, right? And I've got deployed kind of off in its own isolated subnet, a wireless access point. It's actually sitting at this 10.0.0.6 address. Now, that is not on my wireless, my normal wireless LAN that my users are connected to. So if I do an IP config, right, you can see that typically things are on a 192.168.1.1 subnet. Just to kind of get an idea of what that looks like, right? That's my Verizon router, right? So that's my home network. But this particular piece of gear is not on it. It is on a 10.0.0.x subnet. Now, how is it that I can actually get there when I have no subnet access, right? So that I'm in a totally different IP space. And the answer to that is AppGate. Now, if you look at some competing solutions, if I were to try to access that at Jim's point, I would have to go out to their POP and come back in. And that's just not going to cut mustard, right? So if you look at this and I were to ping this local resource, those are some pretty spectacular ping times, right? I'm talking like sub 5 millisecond on average, right? That is a LAN. I'm not going out and coming back and using any sort of internet connectivity for that to happen, which is a boon. And if I were to actually come in here and do a trace route, we can prove it, right? So you'll see, helps if you actually put in the destination. You'll see that it's going to hit my gateway, which is, I don't know if we went into the details of that, right? But gateways are AppGate software components that are going to handle sort of your network traffic and the access control. And you can see it's going to hit that first, not going to get a hit back. And then it's going to go straight to the destination with those beautiful ping times. And that's it, right? I have not gone anywhere else. I have not left the building, right? We've not gone to the internet at all. I have routed directly to that. Now, here's the best part. For you to set this up, it does not require anything crazy at all. AppGate is smart enough to figure out when that user is on a trusted corporate LAN that should not go out to the internet and when it's not. So I added my home IP address to the list of allowed local, essentially data centers or offices, right? So when AppGate says, hey, I see Steve is connecting in from this particular IP address, that means I'm going to route his traffic to those resources locally because I know he's in the office. So you don't have to do any crazy setups. The end users have absolutely no idea what's going on. They just know that they use the same thing in the office that they do when they are remote. And of course, you get all the security benefits thereof. And just to close this out and prove that I'm not completely full of it, right? I'm going to suspend my AppGate client right now. It's going to disconnect me from everything AppGate. And if I were to go in here now and try to refresh this page, if I were to try to ping that system, I'm done. I got nothing, right? Because I'm not connected to AppGate. AppGate's not providing that protected path for me.
Very interesting, Steve. I appreciate that demo. So let me just recap while I'm picking up the screen share again. So I think what you just showed us is that you've got a laptop connected to your Verizon provided Wi-Fi network. You've got an AppGate client on that laptop, and you've configured your AppGate gateway sitting on a different subnet in your environment that says, hey, anything coming from 192.168 is actually local, and route it directly into that through that gateway to that 10 dot network. And you're able to get there in sub 10 millisecond times. That's powerful, right? Did I get that right?
That's it.
All right. I don't think you can get sub 10 millisecond times to anything on the internet, even if it's your next door neighbor's house, right? So good job. Again, complex demo, but I think it drives the point home. Very simple configuration to the AppGate solution, preventing all of that unwanted internet bandwidth charge, whether that charge is in real dollars or in consumed bandwidth. Either way, you're paying the price twice if you're using a cloud routed solution. All right, let's bounce to the next topic. Let's talk about redundancy, right? And with redundancy comes the idea of self-healing. So think about, first of all, let's get this off the table. Single entry points will never get you there. VPN concentrators, single firewalls, other things like that. Yes, you can deploy VPN concentrators in an HA mode. Yes, you can deploy firewalls in an HA mode, but those imply lots of complexity, lots of licensing fees associated with it, extra things with load balancers, oftentimes So yeah, there's a lot of complexity with doing HA with these scenarios. And by the way, you can't go infinitely horizontal with these scenarios. You add a third or a fourth or a fifth, and now you're getting into transferring of state tables and things like that. Reality starts to set in that I can't scale very far with these single entry point oriented solutions. So what does that look like from a cloud-based scenario? Well, the cloud does this pretty well. Cloud routed scenarios, cloud routed ZTNA solutions handle this redundancy concept pretty well. If you think about a cloud-based solution, there's POPs that are often geo-distributed. They're using DNS magic to get you to the nearest POP. That's great. That's why DNS exists. It does some of these fantastic things for you. These POPs can be running in IaaS platforms like AWS, Azure, GCP. And, so therefore these vendors will take advantage of the redundancy and some of the availability zone concepts and other redundancies that are made available by those infrastructure providers. But sometimes the vendors run their own private clouds, right? There are a few that bounce out there and they do data center contracts and they get a cage and they stand up their own physical infrastructure to represent their POP. I think you could think about some implied limitations there. Did they architect it correctly? Did they build it to the right size? Can it handle a growing workload? Can it handle bursts of traffic? All those things start to come into play. Think about it. And by nature, cloud routed is generally robust, right? It's generally available, assuming that it's been architected correctly and assuming there's no service-wide outage. But I think we could all agree that there's no cloud-based service that's been 100% perfect on availability. Cloud-based services are often under attack. I mean, a bad guy could take down a cloud-based service and affect thousands or hundreds of thousands of users at the same time. If that's his mission in life, then why wouldn't he attempt to do that at a cloud-based service scenario? On the other hand, how do we achieve this with direct routed, right? So I think the basic answer is multiple gateways. Remember, in a direct routed scenario, these gateways live on the edge of the data center where the applications they're protecting live. And so the idea that deploying multiple gateways on the edge becomes the way that we create that redundancy within the direct routed solution, Appgate SDP. And then I think you can easily conclude that with multiple gateways, you also get the additional benefit of scale and throughput, right? And of course, any recovery of a downed gateway or an unavailable gateway should be automatic from the end user's perspective. No intervention at all. Did I miss anything, guys? Is there any other color commentary to add there? Justin, maybe you've got some ideas here.
Yeah, no, I don't think that you've really missed anything, Jim. I think that the best way to drive this point home is to see it live.
All right, let's do that. Let's bounce into a quick demo from Justin. Again, thinking about redundancy and perhaps even scalability within that direct routed model.
Yeah. So again, back to our diagram just for a moment here, because I want to show you where I will be demonstrating to you. So again, this is me in the logical center of the diagram, and I'm going to actually simplify this diagram and highlight some of the Appgate components that we've deployed. So in each of these environments, these gated icons that you see represent the Appgate gateways that we've deployed. And so I'm going to be performing this demonstration in our AWS environment in North Virginia, where we currently have 3 gateways deployed to protect the resources that live in that environment. And so as an end user, when I sign in with my Appgate client, my client is told about all 3 of the gateways that protect the resources in this environment. So if I'm served an entitlement that allows me to reach one of these things in this AWS environment, my client knows about all 3 of these gateways, but it only needs to connect to one of them at any given time. And so my client, essentially, the way we've configured our Appgate collective here is such that my client will just randomly connect to one of those gateways. And in fact, I've connected to the gateway that we've called Gateway AWS North Virginia 01. So this is our first gateway there. The other 2, as you might expect, are named 02 and 03 and so forth. And so what I've done here is, if you take a look at here, we have some servers in this AWS environment that live on this 10.201.4 subnet. And I have actually started a ping to this 10.201.4.58 IP address. So I've been served an entitlement that allows me to perform ICMP requests to that IP address. And so I've got that ping running. And what I'm going to do next is I'm going to actually come over to my AWS console. And you'll see here that I've already highlighted our gateway 01 here. You can see the gateways 02 and 03 down here. And we have some other gateways for other functions as well in this environment. But I'm actually just going to reboot this gateway instance. What you're going to see here when I reboot this gateway instance is that if we come back over here to my pings, I lost one ping. So from an end user's perspective, this experience is, for the most part, it's not even noticeable. And a user isn't going to notice a loss of one packet. And in fact, in certain situations, you can actually synchronize the state of the session between the client and the gateway, so that way there, if you have a session that requires a persistent session, for example, something like SSH or RDP, that connection could have stayed up and running as well. And if we take a look again in my AppGate client, you can see here now that I am now connected to gateway 02. So really just automatically, we failed over to the next available gateway essentially. And from an end user's perspective, it's completely transparent. And just to kind of highlight one other thing that Jim said is that while I have deployed 3 gateways in this environment, I did so for purposes of scale and redundancy. There are 2 dimensions of scale with AppGate SDP. You could scale an individual appliance's capacity by increasing the amount of CPU and RAM that's allocated to that instance. We can also scale the solution horizontally by just adding more gateways. And another important bit here, I guess, would be that AppGate doesn't charge you for those appliances if you deploy them as virtual appliances, as obviously you would in a cloud environment. And so therefore, you can deploy as many appliances as is required to meet your scale and your redundancy needs. And in addition to that, we can also leverage AppGate natively supports the auto scaling concepts in the infrastructure as a service platform. So on AWS, Azure, and GCP, we can help you to set up auto scaling so that when capacity is needed, new gateways are automatically spawned and spun up. When capacity is no longer needed, those gateways can even be automatically torn down with auto scaling. So really kind of to help you control costs, but also to always meet your needs. And that auto scaling concept obviously would kick in if a gateway for some reason were to become malfunctional, and the auto scaling concept can automatically spin up a new gateway to replace that the bad one. And so with that said, I think that's the end of this demonstration. So back over to Jim.
Interesting stuff, Justin. One quick question. What about the case of complex applications that are looking at the source of the source IP address of the traffic coming into the application? Does the tunnel IP address transfer from the first gateway to the second gateway when your client reestablishes a connection?
Yeah, that's a great question, Jim. And yes, so my tunnel IP address, the IP address that is assigned to my AppGate client would remain the same across those connections. And with AppGate, we give you a number of different ways to configure how the target application sees that traffic. By default, we let you push the easy button, which is basically just traffic is always going to be natted to the source IP address of the AppGate gateway, but the tunnel IP address that is assigned to me can be exposed onto the LAN as well, and might require some routing changes on your network. And so effectively, if I were to fail over between gateways, my IP address would remain the same.
Excellent. Great demo, Justin. Thank you very much. I think we've tapped into that one. So let's move on to the next topic. So performance and end user experience, right? So how do we judge or gauge the performance of a solution? Well, I think it's safe to say that your end user experience is really the measuring stick. How do your end users see, experience, understand their own performance when using the environment? And I think especially your outliers, right? Outliers being the folks that are furthest distance away, the folks that are the most squawky, or even the folks that constantly experience the worst behavior, right? Those outliers are the ones that the squeaky wheel gets the grease, right? So the outliers are the ones that really define the experience level of a solution most of the time. So I think you got to focus on those folks. But what is it that really drives that experience? So I think that some of the things that happen are the speed of execution, and these aren't easy words that I threw on a slide. You know, think about in the process of encrypting and de-encrypting, because effectively Justin showed his AppGate client, and I think Steve showed his as well. You know, end users in the AppGate world have multiple tunnels going from their device to many different data centers that fulfill your world or your customer's world if you're a partner of ours. And each one of those tunnels is handling encryption and de-encryption on their own, both at the client side and at the gateway side. How does AppGate SDP make this encryption and de-encryption happen as quickly as possible? Justin, can you dive into that a little bit? Have we done anything special there to differentiate ourselves from some of our competitors?
Yeah, definitely, Jim. Thanks. AppGate leverages with our AppGate appliances. We're leveraging some of the latest AES-NI chipsets available on hardware, virtualized hardware, to help to essentially make encryption and decryption services at nearly wire speed. So, from an encryption and decryption standpoint, there's very, very little overhead. It's, again, user negligible is the way that I usually describe it. We're talking order of millisecond or less of overhead that's added by AppGate's encryption and decryption. In addition to that, I guess it's kind of tangentially related to that, Jim, but within the AppGate gateways, for every single user session, there is actually what we refer to as a micro firewall that's stood up per user. And that kind of sounds like marketing jargon, but it's actually something that's very technically intelligent. So if you think about the way that a typical firewall works, you define the policies for it, and there's one giant list of rules that exist in that rule set. And anytime there's a new traffic that's fed into that firewall, the firewall has to run through that entire list of rules before it hits the one that it matches that defines whether traffic should be allowed or denied or whatever. With AppGate, we actually stand up a very small set of firewall rules on a per user basis. And so this actually allows for AppGate to execute very quickly as well. So again, a combination of those actual firewall rule sets being really kind of shrunk down to a microscopic size, and then again, being able to apply wire speed or near wire speed, excuse me, encryption and decryption really kind of helps AppGate to stand apart from a performance perspective.
That's good stuff, Justin. I appreciate you giving that color commentary. Continuing down the slide, think about, I think you touched on speed of execution with encryption and decryption, but also the connection speeds themselves, achieving near wire speed within the gateways. That's important, right? And so I think, Steve, maybe you could touch on the fact that because we can achieve near wire speed with gateways, what does that mean when you've got to scale beyond, what a single gateway can do? What does that mean in terms of the AppGate SDP solution in comparison with a cloud routed solution where you may have, you may not have that level of efficiency. You may need more entry points into the data center. What does that actually mean? How does that translate?
Yeah, that's a great question. So I think it's a question about effectively and efficiently utilizing the resources that are available to the solution, which is a lot of words to say. Are you actually properly utilizing CPU, RAM, and NIC the way that is most effective and efficient? And I can tell you for sure, if you're talking about another vendor solution that has you install a service on top of Windows or Linux or adds an agent on the machine, no, right? You're already going to be competing with an operating system, maybe all the other resources that are going on there, and just it doesn't make sense at all. If you think about some of the competing solutions that are out there in the cloud routing world, it's kind of intuitive to gloss over the fact that there's always going to be a component in your data center, right? It's not magic. I can't get packets into and out of a network just all on my own, right? You've got firewalls, there's rules that are in place. You're not going to just have your traffic open to the world. So you're going to need either a gateway in the AppGate parlance, some other people call them app connectors, right? Lots of different words that mean the same thing. There is some infrastructure that you as a customer are running to get bits and bytes from point A to point B. And they need to be extremely efficient. Typically, right, I'm just kind of, we'll leave names out of it, but when we talk to customers, right, some of the major players out there in the ZTNA space are speccing our customers tenfold the number or the compute resources required to do the same amount of performance that AppGate is getting. So there, you really have to think about total cost of ownership, right? How many ingress boxes, we'll call them that, do you need to get the job done? In the world of AppGate, it's going to be way, way less than pretty much any of the other competitors out there.
I think that's critical information, Steve. I think those fall into the bucket of hidden costs of making technology choices. So that's good data. Thank you for that. Let's keep going with this performance thing though. So also tied to performance is really things that you can't solve for. I tend to call them speed of light problems, right? Packets on the wire will only travel at a certain speed, and they can't defy the laws of nature in physics itself. So what happens when you don't route directly to the data center from the end user's device and you have to go through a POP? Describe that scenario real quick in terms of, routing to the POP, hitting the POP with a hop or multiple hops, and then routing back to the data center. What's the reality of that, guys?
Yeah, so the reality is it doesn't matter how many how many pops around the world your ZTNA provider claims that they have and how fast their backbone is. You are, by sheer nature of cloud routing, you are artificially sending traffic in a path down a path that it doesn't need to go. The most optimal way that your traffic will reach your resources that live in your data centers or your cloud environments is going to be directly to a policy enforcement point that lives at the edge of those networks. And that's ultimately what AppGate helps you to do.
And so I think what's implied there is that AppGate SDP can actually leverage really any layer 2 network between the end user and the data center where the resources live.
Precisely.
Be that the public internet and a direct connect, an SD-WAN, an MPLS circuit. And so talk to me real quick about what happens when we run into customers that are actually leveraging, say, an MPLS network or maybe an SD-WAN circuit, set of circuits between their facilities. How does AppGate have an impact there? Do we compete? Do we have a positive impact, or do we stay out of that world? What happens?
It's entirely up to the customer. Ultimately what it comes down to is, again, those what you've just described there, MPLS, SD-WAN, those are all layer 2 networks. So from an AppGate's perspective, AppGate is an overlay solution. We don't care if you use those solutions. If you need them, continue using them, that's fine. But in some cases, AppGate can help you to reduce costs by actually mitigating the need for using those types of technologies, legacy things like MPLS to interconnect your facilities and so forth. Because of the nature of the fact that AppGate can help you to get a highly performant connection between multiple locations all at the same time, we can, in a lot of cases, again, can help to mitigate the need for even maintaining those investments in those types of technologies.
Okay, excellent. That's good stuff. So ROI, is can be nearly instantaneous given the right circumstances. If you could minimize or reduce your MPLS circuit costs, or maybe even think about, eliminating your SD-WAN if that's something that you don't necessarily need once you implement AppGate. So that's great stuff. Let's keep going here. We're running out of time. We're down to the last 15 minutes. So let's talk about access methods, right? So, it's no strange fact or no unwritten fact that most cloud routed solutions usually deploy some sort of reverse proxy for their access methods. Whether that reverse proxy is sitting in their cloud-based POP or it's sitting on the edge of a network, usually there's a reverse proxy that's in play. It's quick to deploy. Kudos to the cloud routed companies and solutions out there to do that. It's easy to deploy, but I think that most customers would find that it's limited in terms of ports and protocols. Yeah, you can have a web proxy where you're only going to protect web-based applications. That's pretty limiting. You could have a protocol-based proxy where you're only protecting TCP traffic, right? That's another concept you could do. But typically, you're not going to support protocols natively like you would in a firewall, right? And so I think that's an important concept to think about. And so, AppGate SDP deploys this direct routed solution, and as Justin already said, dynamically establishes these ephemeral firewall rules. And by ephemeral, I mean that as the user connects, The individual gateways will have firewall rules established for that user's connection, private to that end user. It's built during their session setup. And then when the user disconnects, those firewall rules go away. They're ephemeral. They don't have any long-term meaning. So when they terminate their connection, those firewall rules will be eliminated from the environment. And as we know, it's those outlying, never touched firewall rules that are often exploited by the bad guys. You know, you forget that you made the exception, you forget that you put the rule in place, you left it in, and all of a sudden, it's exploitable. There's some way into the environment by something that you forgot to do. So we're talking just-in-time firewall rules built at session initiation, and then let's touch real quick on the update throughout the session comment that I've put in the slide. What does that actually mean, right? How do we update firewall rules in the middle of the session? Steve, maybe you could take that one and help us understand what that really means.
Yeah, absolutely. So AppGate is a tokenized solution at the end of the day, right? We have access tokens that are in play, and those are going to be, revoked or reissued if a change in access based on policy comes into play, right? Again, lots of words. What does that mean? AppGate is continuously monitoring a session. It is continuously adjusting those firewall rules for individual sessions as changes in context happen. So I'm going to actually pivot over to my screen real quick, and I'm going to show you kind of how those changes in context can manifest themselves, not only on the end user side, but also changes in context on the workload side. To Jim's point, right, we open up firewall rules, we have a backdoor to our SSH, somewhere, and guess what? That employee leaves the company, or they just completely forget, and now you have an open hole in the firewall. Nobody wants that. So how do you get away from that? How do you have these kind of contextual changes on the fly for individual users? So let me share my screen. I'll give you a very, very real quick idea of what we're talking about here. So to Jim's point earlier, right, we don't really care what kind of protocol you use. It doesn't need to be web, it doesn't need to be SSH. And if you kind of look through my list of what we call entitlements, which is just a definition of access, right? I'm covering a very, very broad spectrum of different types of traffic, going to different types of destinations that are all defined differently. Defined differently because I want to be able to choose as the admin how I'm structuring and architecting my network. So let's take a look at this real quick. So if I wanted to, give somebody access to an individual server, cool, no problem, right? I got an internal site that I got here, and it's a web server. Great, fantastic, no problem there. I could also say maybe I want to have multiple hosts defined for something. So I could create a rule that says, hey, look, you got a handful of IP addresses, you need SSH access to those too, great, no problem. And you can keep going, right? You can do Sitter blocks if you'd like to. You can do actual domains. So again, you can do but here's something that's really cool, and it's going to kill a few birds with one stone. There's the idea that we have of resolvers. And if you look at, we're going to pick on, let's see, AWS North Virginia. This is implementing contextual awareness on the workload side. So I can actually, with AppGate, look at metadata on the destination and marry a user's access to that without knowing anything about IP address changes, whether or not security groups have been messed with, right? It doesn't matter. And real quick, let's look at this. I have granted my session, right, not me personally, but my AppGate admin, access to things in AWS that have this type of metadata, right? There's a tag on my instance with a key value pair of mode equals QA. It's got to be in the right region, and it's got to be the right account type. And if those things are true, my user is going to have web, RDP, SSH, and ping access to that, right? Great, fantastic. But what happens if the metadata changes? What happens if maybe the tags on that box change, or maybe the IP address changes, but the tags remain the same? Traditionally, you would have to go and make changes in admin to your policy. That's step one. And step two is that user would have to do something to get those changes reflected. Not in the case of AppGate, right? Those are going to be continuously adjusted. So let's do it real quick. Kind of suspend your disbelief for a second. I probably shouldn't be able to do this as the QA person, but let's say that DC Ops comes in and they promote this particular instance from QA to UAT, right? Before I do that, let's actually start a ping. Otherwise, you won't be able to see it. Go back to our QA box. And I also should point out there's no public IP on this, right? So I am tunneling this traffic through AppGate. We're going to ping this instance. I'm going to paste that 10.201.4.176. We're going to let that go. However, I'm going to go in here. We're going to update the metadata here. So change in context on the workload side. Where's my mode here? And we're going to save this. Now it's going to update on the AWS side. It's going to take that change, right? It's going to tell me that the request to manage the tags were successful. And I'm out. I am done. My network path to that is gone. And I'm just using ping, right? So you can see the packets flowing back and forth, but it doesn't really matter to us what kind of application traffic it is, right? That's a Power AppGate contextual real-time enforcement.
If I could
So-
add one more I want to dive one more level deeper on that, and that is that I think one thing that oftentimes happens is we'll grant access through some legacy technology to some static IP address, and eventually at some point down the line that instance or that target goes away. It gets removed or whatever, and oftentimes administrators will forget to go close up the hole, otherwise poke through a firewall or VPN policy granting that static access. And so by using these metadata resolvers, if the instance doesn't exist anymore, then the IP address is no longer accessible to the end user. So another advantage to this kind of metadata resolution-based approach to access.
So Steve, just to recap, I think what you showed us was the idea that as an end user, you were served an entitlement that's based on a metadata query, and your client handed that query to the gateway and said, execute this for me. And so the gateway is responsible for executing that query on a periodic basis, right? And you showed us in Amazon how that works. What other platforms do we support such gateway-based querying?
Yeah, well, the sky is the limit, really, when it comes to extensibility, which we don't really even have time to get into. But for kind of the canned integrations to hypervisor platforms and public cloud, it's all the major players, right? AWS, Azure, Google Cloud, VMware, right? Hypervisors, all those are fair play, right? The individual names are going to be different, right? Not everyone uses the terminology tags, right? You might have vSphere folders and things like that, but the concept is exactly the same, right? We're talking about changes in workload context directly can translate to changes in end user access without anyone having to do anything.
That's great stuff. Have we done any integrations with other vendors out there that maybe somebody that is adjacent to us in terms of east-west traffic and things like that within the data center?
We have, absolutely. So if you kind of take a step back and say, all right, let's talk about workloads that are platform independent, right? Maybe they run all over the place and a bunch of different things and something that you created yourself, who knows? We partner with folks like Illumio to ingest information and metadata from them. So Illumio labels are a great way for organizations to tag role information about a workload. Maybe they're quarantining workloads, right? The sky is the limit again over what kind of information you're encapsulating in those systems. But AppGate can read those in extremely fast manner and make adjustments on the fly for all of your sessions.
Great stuff. Great stuff. All right, let's move on to the next topic. So let's talk about shared information. This is a touchy subject, and I think one of the things that a lot of cloud-based vendors don't necessarily want to expose in a pre-sales kind of concept. So it's something that you end up inheriting after the fact. So what is shared information? Why is it that the cloud-based solutions need information that the direct routed solutions don't? Things like perhaps your LDAP databases or your DNS zones or other things like that. What's going on here, and why is this a thing? Maybe Steve, maybe you could touch on this for me real quick.
Yeah, for sure. So typically the answer to that question has to do with information path, right? How is that system, that ZTNA system that's living in the cloud, going to figure out whether or not your user provided correct credentials or whether or not their antivirus system is up to date in a particular situation unless they have some communication channel to resolve that information. If you're in a direct routed scenario, that information is probably co-located with your systems, right? So you can go out and live query an LDAP database and say, hey, are these valid credentials, right? And I don't need to cache those. It could be a live query. I can pull back other information from that source of truth, like what role information, group information do I have about that user, asset information, and all those things can go very, very fast, very, very locally, while at the same time being able to support all of the other types of communication exchange, like SAML or OIDC, things like Radius even, right? All the stuff that when you live in the world of cloud are kind of difficult to do without having to go out and deploy LDAP connectors and connectors here, connectors there. It just doesn't scale very well. It doesn't make a lot of sense. And typically you end up having to get constrained to maybe one identity provider, a handful of identity providers. And it doesn't make sense and it doesn't need to be that way.
So it's a scenario of either share your private info or be limited to the least common denominator from the cloud providers, typically what customers run into. I think that's what you're saying.
You said it better than I did, yes.
Justin, maybe touch on this, what it can lead to column that I've added to this slide. I think one of the most important things is data custody. You know, who owns the data and how protected is it? Touch on this for us for a little bit.
Yeah, I mean, absolutely. It's ultimately we're here to talk about zero trust, and obviously that's a term that's kind of probably, as we kind of set up at the beginning here, it's way overused in our industry. But the whole idea here is to minimize what you trust, or and really only grant access under the appropriate circumstances and so forth. And so, from a data custody perspective, I mean, why trust some other third-party entity with your data and your network traffic, and when it's not necessary? That's really the whole gist of it. I mean, there's a whole lot here that we could dive into, but I can't really say it any simpler than that.
All right, we got 2 more minutes on the clock. Let's hit the last topic here. So, hiding your network with SPA. What SPA? I love a day at the SPA, but in our case, SPA stands for Single Packet Authorization. If you think about it, all of these services into and out of your data center are really exposed ports to the public internet. And these exposed ports are often either forgotten about, not managed and maintained properly, and ultimately exploited, right? Go check the CVE database on MITRE.org, search for your favorite vendor. It's public information, and every vendor is obligated to publish their CVEs that are found, their 0 days, their attack vectors, things like that. There's the URL. You can check it on your own if you've not looked at it in a while, but look for your favorite vendors out there. How do we solve this? How do we do, in a direct routed scenario, how do we prevent those appliances that are gateways deployed on the edge of a corporate data center? How do we prevent them from being attacked by the outside world? What is this single packet authorization thing? Mr. Justin, how does that work?
Yeah. So essentially, the AppGate appliances do have to sit at the perimeter of your network. In most cases, they are going to have a public IP address. However, they are protected using this thing called SPA. And SPA effectively makes all of those appliances invisible to anyone who's not authorized to access them. In order to communicate with an AppGate appliance, you must have an AppGate client that is pre-configured with a profile that includes a valid SPA key. And that SPA key is something that your organization owns and manages and can issue and revoke it at any time. You can create as many SPA keys as needed to serve different purposes. But ultimately, without an AppGate client with that valid SPA key, you can't get a response from one of these appliances. So if we contrast this with other access technologies that don't utilize SPA, like VPNs, for example, every single VPN on the planet is going to have a common theme in that it will always have an open listening port that must respond to any device that tries to connect. Obviously, that means your end users can connect to your VPN from anywhere in the world, but unfortunately, it also means that the bad guys can discover the VPN by way of a port scan. And so what this ultimately comes down to is that that'll leave you vulnerable to denial of service attacks, zero-day exploits, and other nasty things that are in that CVE list that Jim pointed out. And AppGate is virtually immune to those types of problems because of the fact that you simply can't find those appliances without an AppGate client that's properly configured. And even if you somehow knew that one of those appliances existed on the network, you could never connect to and get a response from it without a valid SPA key.
Good stuff, Justin. Thank you for that. And again, we're a little bit over, but let's wrap this thing up, right? So as a review of what we've discovered today or what we've talked about today is, why is it that direct routed architecture matters? So in a single slide, there's a list of bulleted items here. Think about, full network traffic control, multi-protocol support, direct access. Steve demonstrated with his home data center. We talked about extensive protocol coverage, on-prem users versus remote users, legacy applications with the broad protocol support. And this doesn't necessarily even just limit itself to users accessing services. You can apply this to IoT devices, headless components. We saw the headless demo as well. Device with AppGate installed on it, but no user logged in, typically what we call a headless scenario. So a lot of different things here. Think of this as a summary slide. I think we've covered off on most of these topics. I want to put a little plug in for next month's Table Talk, coming on February 27th at 11 a.m. You can register on our public website the same way that you registered for this one if you're interested. The next one is going to be very federally focused, talking about tactical edge operation and how you can use AppGate SDP to secure that platform, including the idea of completely disconnected access to applications. They may actually be running in your backpack. And how do I control access locally without using any network other than what I'm carrying? So that's a concept that we'll touch on in the next Table Talk. And then finally, if you're interested in digging a little deeper, we do have a ZTNA free trial that's out on our website. You can register for a free 30-day trial, no contracts. Pop out to that URL and get started. The idea there is that you can register. You'll get pre-built for you, automatically deployed for you is a controller, a set of authentication methods, and a method of walking you through defining and building the extra components that will provide protected access to some asset that you want to demonstrate within your own environment. And again, I want to thank everybody for jumping in and giving us an hour of your day. Recordings will be coming out in due time. We do have a list of questions that have come in, and I'll attempt to try to answer some of those on the side. But if you've got other questions, you can hit us at firstname.lastname@appgate.com. And I'm Jim Anthony, your host for this session. And again, thank you for joining. Thanks, guys, for your support.